Welcome to today's lesson, and in this lesson we're going to be looking at LCD touchscreens. They're an item that I find extremely useful, especially when building control panels. As you can see on the screen, we've got a couple of touchscreens there. The top one is a shield type, little 2.4 inch one, probably one of the cheapest touchscreens you can buy. And below is a bigger 3.5 inch touchscreen, which is on a breakout board. The main difference is that obviously the top one will fit directly on top of your Arduino Uno or a Mega 2560. The bottom one, you've got to sort of build the wiring yourself. Anyway, let's have a look at what we're going to be doing today. So the schedule for today, we're going to look at setting up the screen, dealing with the screen rotation and resolution. Then we're going to be looking at how to set the touch system up. After that, we're going to be calibrating the touch system to the screen, because unfortunately they don't work with the same resolution and even the same rotation at times. And then we'll create a few sketches, but the final sketch will be finishing up creating a simple button sketch where we can press a button on the screen and it'll do something for us. So that's the plan for today. So let's start to look at the IDE. So I've got the IDE open, and just before I start, we're just going to have a quick look at the different touch screens that I've got here. Now, the one at the top here that fits onto a shield, if it goes onto a shield, it will usually be 5-volt tolerant. The breakout boards, you'll notice that it's 3.3 volts. Now you might think you could just connect your 3.3 volts power from your Arduino Uno or your Mega. However, all the pins are also 3.3 volts. So if you attach your 5-volt Uno to these pins, you're probably going to trash your screen. So if it's on a shield, it will usually be 5 volts. Again, check your documentation. If it's on a breakout board, it'll probably be 3.3 volts, and for that either you need a logic level shifter, which is a little device that goes between the pins on the screen and the pins on your Arduino that changes the voltages, or you could use a 3.3 volt Arduino. Now for this example, I will be using an Arduino Due. If you've never seen one, take a search on the internet. They look like an Arduino Mega. They use a different processor. They're faster than the Mega. In fact, they're a lot more powerful than a Mega. But the good thing about them from my point of view is they're 3.3 volts. They have a lot of pins, just like the Mega, and because for my own purposes I'm going to be building this as part of my oscilloscope project, the extra pins will be very, very useful to me. Now, the other thing that you need to know is that we're going to be using some libraries. The libraries that we will be using will be the Adafruit's GFX library. We will use the Adafruit touchscreen library, and we will use the MCU friend _KBV library. Now obviously if you can't remember that, if you go to the Digital Town website, the link will be under the video. I've listed the libraries there, and the way that you find the libraries, if we're in the IDE, go to Tools, Manage Libraries, and then we'll put the first one in. MCU friend, just put the first few letters in, and there we are. We have the MCU friend library. Install that one. Do exactly the same with the Adafruit touchscreen and the Adafruit GFX library. Now I would advise you to go to the Digital Town website and just check the spellings of those libraries, because unfortunately if you misspell it very slightly you could finish up with some other libraries. Now just as a quick one of what's going on here, so in this first sketch I've listed the screen that I'm using. I'm using a 3.5 inch open smart screen. It's this lower module here. The reason I'm using this module is that it is much easier to fit into a control panel. The problem with this type of screen is obviously you drop your Arduino onto the back of it, and even if you can mount it in a fascia for your control panel, you've got a lot of weight hanging off the back of the screen. So I prefer to have basically the screen screwed into the front of my control panel and the Arduino sat separately. That's my personal preference. Obviously you can do things as you want, and certainly if you're just playing around on the desktop, these topped small 2.4-inch screens are absolutely great, and they're only a few quid to buy, so well worth owning. So onto the sketch. So what I've done is I've listed the type of controller I've got. Again, going back to the picture, you will see I have my controller listed here. Usually when you buy a screen, it will list the controller type on it. And one of the things that you will need to do is when you load the MCU Friend library, you just need to make sure that the particular screen that you're using has been uncommented in this file in the library. So in there is a whole list of different screen types, and obviously you don't want every screen type included within your library, within your sketch, because it would be huge. It would slow the whole thing down. So you tend to just comment in the one, uncomment the screen that you want to use. So going through the sketch, first things first, if you're not using a shield board, you'll need to obviously wire the thing up, and I have included the pinout diagram here. It's exactly the same pinout as it would be on a shield, but obviously you've got to figure how to set that up, and there is a sketch again on the Digital Town website. There's a photograph of my current project, how I've actually soldered that all together. So we've talked about the MCU Friend _ KBV library. We've also got to add the Adafruit GFX library. And then as we go down the sketch, the first thing we do is we create a touchscreen object from the MCU Friend KBV library. I'm not going to explain how that works. This is the blessings of a library. You just need to understand that that line needs to be in there. Now the next bit we've got is a variable which we're going to call touch orientation. We're defining this, and I've given it a value of 1. That's because from my experiments I know that 1 is landscape. So if that was a 0, it would be portrait, and you can see in the line above you can go from values 0 to -3, and you'll see in some of the photographs later on that my screen, I'm actually working on it technically what you would call upside down according to the writing on the screen. The reason for that is that I want it mounted in my enclosure in a specific way so that the pins don't interfere with anything when it's in the correct position. Now the next bit was I have defined some colors that we will use within the Adafruit GFX library. It uses these hexadecimal values for colors. Now I've got some examples in here of a range of colors. You could just put the hexadecimal value in the code, but to be honest I just can't remember that red is F800, so I've got some preset in here. I've also got a link in the script to a web page where if you go there, there is actually a color generator. So you go to that web page, move the colors around until you get the color that you want, and it will actually give you the hex color. So I could actually define my custom color and put my own value in. Okay, so as you can see, it's a very simple set of code so far. We've got the standard setting the serial up in the way that I always do. Then as part of the code we're going to read the ID for the touch screen. This is using a function read ID from the MCU Friend _ KBV library, just to give you an idea of what's going on here. The Adafruit GFX library deals with how you draw the actual shapes, your rectangles, lines, whatever, on your screen. The MCU friend underscore KBV library acts as a sort of a bridge between this library and the electronics of the screen. So basically it runs a translation system. So in my case, it's going to know that I'm going to be using an ST7793 is the sort of graphics processor that it's got to talk to. So that's a lot of work that's done by this library, and I'm very thankful to the person who wrote that library. So going back to this, we've found the screen ID, and then what we do is in the library we are turning on beginning that screen. So basically we're saying to our touch screen, get started. The next line sets the rotation, which is the touch orientation we've set up here. As you'll see later, if your screen is reading the wrong direction, or you might want it portrait, I happen to want mine landscape, or you may be mounting yours the right way up instead of upside down like me, change the value at the top here until you get the screen laid out the way you want it. Now the next thing we're going to do in our script, and it's a very short script, is we're going to fill the screen with black. So if you've been doing some experiments or you've already got some stuff on your screen, it doesn't just delete itself, you have to remove that color. So this instruction here, fill screen, fills the entire screen, and I'm setting myself a black background. And then the next thing I'm doing is I'm drawing a rectangle. This is, when you see this bit, it's using the Adafruit graphics GFX library. So what it's saying here is I want the top left hand corner of my square to be 0, 0, so that is top left on my screen, and then I'm going to make the square 10 pixels wide by 10 pixels deep, and the color of my box is going to be white. And if everything goes well, apologies for this absolutely awful photograph, I've still got the protective screen on, the reason being someone sent me some screens and they've sent me the wrong ones, so they might have to go back. But as you can see, I have got here a little white box in the top left hand corner of my screen. As you can see, my screen is set sort of in an upside down position because these pins need to be over here for the case. But if everything goes well and you've got it all sorted, you will see this little box in the top left hand corner, and that helps you then to know that that is the screen orientation is all set out correctly. Now if your screen orientation is set out correctly, what I'd like you to do then is to go down a little bit further, and all I want you to do is uncomment this line here. Now my screen is 400 pixels by 240 pixels, so I'm going to start top left position 0, 0, and you'll notice it's 400 pixels, so the first pixel is 0, so pixel number 400 is actually 399, and again pixel 240 is 239, and this time I've chosen the color red, and I'm going to draw a box round, and if it has all come out correctly, again apologies for this awful picture, I had to turn the lights out because I suddenly realized red doesn't photograph very well, but you can now see my little white box, and around the edge of the screen is a red box. Now obviously on yours, if you're using a different resolution, I've got touch screens that are 480 by 340, some of them are I think 240 by something, certainly the little touch screen, they're all different, so you will have to change this line to suit the touch screen that you are using. But the goal of this script is that when you've finished, you've got a little white box top left, and then you've got a box that's going as a boundary all around the edge of your screen, and if you've succeeded with that, you then know that you've got your orientation correct and you've got your screen resolution correct. So now we've got the screen orientation and resolution set up. The next part to deal with is the setting up of the touch system. Now unfortunately the touch system is a little bit of a pain because your screen may be 400 by 240 or whatever resolution you bought, but I can assure you the touch system does not work to the same resolution. So we're going to do this in a couple of sketches so that we work through it and you understand fully what's going on. So going through the version 2 script, and again it's all on the Digital Town website, so just click on the link. We've got the graphics library as before, MCU KB_KBV, all the rest of it. Everything is the same until we get down to here. Now in the MCU Friend KBV library, when you install it, if we go up to File, Examples, MCU KBV, so we'll go down, there it is. If you go into the examples, you will see different example scripts that you can just click on, and most of these will actually just run on your screen immediately if it's set up correctly. But there is one particular script, Touch Shield New. So again, let's go down to those examples. Touch Shield New. When you start that script, it gives a few values and it will give you these pin values. Now they change depending on the particular screen that you've got, so I can't tell you in advance what the values are for your screen, but if you've got through the previous part and you run that script, it'll give you these values. So once you've got those values, even though we don't really understand what they are, we just put them in. Include the touchscreen library. Now this is the Adafruit touchscreen library for when you're selecting it in your library's library manager. Don't just type in touchscreen or you'll probably finish up with a wrong library. Now how it starts itself. So TS, it's a bit like up here, TFT is our object for the screen display. TS is our almost like doing the same thing but for the touch screen. It then takes some values, does its stuff, and then it creates a touch point object, TP. Again, you don't need to know the full details of this because this is the wonder of libraries. But the big thing that you've got to get right is this one line here, and that needs to come from that particular script there. I found it was displayed on the first screen when you run that script. Okay, the setup is exactly the same as the previous script. The only thing that I have changed is the boundary box to yellow. That's so that when I was taking my photographs I knew which one I was on. And as soon as it starts, I'm just going to bring a picture over here. Sorry, we don't need the picture yet, just realised, yep, we're on the previous script. So what happens is, if you look on the right hand side, I've got the script running. You're going to see 3 sets of values. If we go down here, this is the bit of the script that deals with the touch point. So TP equals basically get the touch point. Now these various bits are just sending pins back into their correct state, ready for the next time that this function is called. And then all I'm doing is I'm printing out the values from getting the touch point. So we've got an X value here, tp.x, we've got a Y value, tp.y, and you've got a Z value, tp.z. So let's explain this. Obviously you think of X and Y left to right on your screen. Y you tend to think of top to bottom. Z is actually the pressure on the screen. So looking at the results, and this is the thing to think about right now, nothing is touching my screen, and you'll notice I'm getting a set of values. Now at this point, if you are getting those set of values, you've basically succeeded in setting up your touchscreen. And if you want a little bit of a play, if you move your finger, as I'm going to do now, over the touchscreen, the first thing you'll see is that the value on the right, TP, changes because I'm putting some pressure on. As I move my little pointer across my screen, I'm using the little stylus that came with it, you'll see that the X and the Y value change as I move it to different positions. As I take the stylus off, we go back to -1. So if your screen is doing that at this point, it means that you have got your touch system set up correctly, and we'll move on to the next screen and start to look at how we integrate that with the LCD screen. Now in the last script, and I've still got the that loaded on my Arduino, I just want to show you something very quickly. I'm now putting my little touch sensor in the center of the screen, and I'm going to move it to the left. Now if you look as I move across, I'm trying to keep it in as straight a line as possible, it is the Y value that is changing even though I'm moving it on a left to right basis on my screen. Now if I take the probe off and take it to the top of the screen and start to move it down, you can see that the X value is changing. Now one of the reasons that I got you to draw a little boundary box around your screen is what I would like you to do is first of all move the probe over to the left until the probe is on top of the boundary line on the left hand side, and just take a note of the value that it gives you. So if you can look on mine as I'm bringing it across, as I get to the line, I'm getting a value there of what, 937, and if I move it across to the far right hand side of the boundary box, it gives me a value of about 140. So I've got a value there, 937 to 140. Then again, moving to the top of the screen, move the probe to the top, and as you can see I'm eventually getting an X value of about, let's try and get that on that line there, it's about 170 I'm going to give it is the top, and the bottom value as I bring it down, it's about 847. Okay, now unfortunately I've had to change screen since I did my experiments earlier, but those numbers are going to be important as you'll see in a moment. So after playing about and doing a little bit more experimenting and moving my pointer, as you'll see in the code here, moving to the pointer to the far left of my screen gave me a Y value of 934. Moving the pointer to the far right of the screen gave me a Y value of 130, and it's worth playing about just to get this right. Now one thing to be aware of, the reason we drew the boundary box is you'll notice that you can actually move the probe outside of the boundary box, so you're outside of the area that you can display on, but you can still read the touch system. So yes, the touch system does not line up exactly with the LCD display. That's the reason I drew the boundary box round, so that I can see where I was supposed to move the probe to get to the edge of the screen. So 934 minus 134, I've got 800 touch points going left to right on my screen, even though my screen is only 400 pixels. So again, as you can see, the number of touch points is not the same as the pixel value, and this is why things can be a little bit confusing. The other thing to be aware of, depending on your screen and depending on the orientation, that might not have been the Y value that moved on yours, it could have been the X value. So just be aware, depending on the, if you like, the orientation of the touchscreen system does not change when you change the orientation of the graphical display of your screen. So this is why this little bit of code that we're going to do now. It's a bit of a pain, but it's how we basically calibrate the two together. Now moving the pointer to the top of my screen gives an X value of 162. Moving the pointer to the bottom of my screen, should have said 840. 840 minus 162 gives 678 points from the top to the bottom on a 240 pixel screen. So as you can see, that is a huge difference. So we've done all this so that we can now match the touch system to the graphics system, and we'll see that in the code below. So this little bit of code, and this is the real pain bit, is how we are going to get the true, what we really want is that when we touch on pixels, say 10 pixels down and 10 pixels across, we want to know our touch X and Y to be exactly the same. So I've created two integers, X touch and Y touch. So what I want is X to be from the far left of my screen to the far right, and Y from the top of my screen to the bottom. 0 obviously going to the maximum number in each way. So to get X touch, don't forget my screen is completely upside down and wrong way round. So I've got a touch screen value that came through, TPY. Even though I'm doing X, because of the way my screen's rotated, I'm having to use the Y value. I then subtract 130. My Y value was 130. So, and again, I've tweaked this by playing around a little bit to get the exact value. So because the screen value, when I move to the far left, let's move it across, sorry, to the far right, because it's running backwards. As you can see, that Y value is dropping down to about 130 there. So if I want to start at 0, I've got to give my TPY value minus 130. Now because mine is reading the wrong way round, I then have to take 800, which is the value of my 934 minus 134. I've worked out that it's about 800 stops across the screen, 800 touch points across the screen. So I've got 800 minus TPY minus 130, and then I divide that by 2 because I've got 800 touch points but I've only got 400 pixels, and that will actually mean that my value now gets reversed and works out correctly for my touch screen. Now when it came to Y touch, one of the issues, and I've got the equation here, this time I don't have to reverse the screen, because if I move my pointer now to the top of my screen, you can see that the X value is going down. If I bring it to the bottom, the X value is increasing, so at least the touchscreen system is working the right way round there. So the top of the screen was 162, so I take the value of TPX minus 162. But if you remember, there were 678 touch points. Now 678 divided by 240 comes out at about 2.8. Now I could just put the equation in like this and that would be fine. However, microprocessors hate decimal points. It slows their calculations down. So to speed the calculations up, because I want to be a nice responsive system, I've taken the value of TPX minus 162 and I've multiplied it then by 10. And then instead of dividing by 2.8, I'm dividing by 28. It just keeps it into whole numbers, which then it will round off to a whole integer. And that will give me my Y touch point. Right, so we've got our X and our Y touch point. What I have done is I've commented out this serial print line here just to make the screen a little bit easier to read over here. Now, at this moment, I'm not touching my screen, and you can see that I'm getting some values here. don't worry about that. If you remember when we were looking at the screen printout earlier, we were seeing a touchscreen value of -1 for pressure, and yet it was still giving an X and Y coordinate. Now what we'll do in the next sketch is learn how to clean that sort of rubbish out, but let's look at what we've got here. So I've got an X touch and a Y touch. I'm now going to put my pointer into the center of my screen. I'm now moving it across to the very left hand side, and as you can see, the X value is going down, and the perfect example there is I'm on the borderline and it's 0. Now as I move it across to the right, we know my touchscreen is 400 pixels wide, and as you can see, I'm just putting it on the edge there, we're just about getting it. Hang on, it's just sticking a bit. There we are, 399, we're just about there. Going to the top now, my Y value drops down to 0, bring it down to the bottom, my Y value gets to 240. I'm having a little bit of a trouble here because I'm trying to watch the screen and not go over the line at the same time, but you get the idea. Now the other thing that I've done, just to make this easier for you and to see if you've got your targeting system correct, is we're going to draw a single line from the top left hand corner, 0, 0, to the X touch and Y touch positions, and we're going to draw a blue line. So every time you touch the screen, or basically every 0.1 of a second, because there's a delay in here, you should see the following. Well, I say that you should see the following, but I hope that your eyesight is better than this. It's an appalling photograph. I'm trying to hold a camera while moving the probe across a screen that I've also got to hold in place. But the idea is that wherever you touch, a little blue line will go from the top left hand corner to the edge of your touch probe, and that way you'll be able to check that your targeting system is the right way round. And again, if it's not hitting where it should do, you're going to have to do some messing around with these two lines to get it sorted out. So that's the end of this sketch. What we're going to do next is we're going to take all of this and turn it into a very, very simple function that can be used within any other sketch, because the problem with this at the moment is it's filling up the main loop and it's a mess. So let's move on to the next sketch. So in this sketch our output will be exactly the same, except that I hope that your little blue lines are in focus and not like my photograph. So you'll notice everything is the same, but when you get down to the main loop, there's one function here, screen press. So let's go back up and see what I've done to change things. Here is the function that we've created called screen press. If you don't understand functions, again, Digital Town website, I did a lesson on functions, so take a look at that one because I'm not going to explain it all now. So I've moved my X touch and Y touch from out of the loop, and they've been put in here, so now they've become global variables. I've also added a new global variable called touch time, which is going to store the time in millis from the time that we last touched the screen. You'll often hear when people are building Arduino projects, when they talk about buttons, you'll often hear them talking about debouncing the button. Well, debouncing the button is when you press a button, as the electrical contact is made, the contact can sort of flutter a little bit and switch on and off many times in a second. So if you're saying to your Arduino, do something when I press the button, it might actually do it 10 times as you press the button once. Now exactly the same sort of thing happens with a touch screen, in that as we touch the touch screen, we don't just touch it for a fraction of a second. Our finger or the probe is on the touch screen for a small period of time, and we need to make sure that we're not recording multiple touches instead of a single touch. Now this next one, I've got an integer here, debounce sensitivity, and you're going to be playing about with this for yourself. I found a value of 220 works really well, but this is, if you like, an adjuster that you can use to alter the sensitivity. So if you set the value too low, you'll get false positives. If you set the value too high, the whole touch system becomes unresponsive. And I've got another integer that we're going to call touch event, and we'll explain how all this is going to work as we go along. So this is the function screen press. So this is called constantly from the main loop. So because we've got no other code in here, this will be running round and round in circles like an absolute racing car. And what it does is it prints to the serial port, the X touch and the Y touch, and it also then draws that blue line. Now if you look over to the right hand side to the COM port, I'll just open the window again just so you can show, nothing's happening. Now if you remember before, we were getting lots of false values, and all of those have been removed within this code. So we understand very easily what's going on here, but what we need to now do is find out what's going on with this line where this value comes from. And all of this comes from this function that's called within the function. So within the function screen press, I've created another function called process touch. We see this function here. Now you'll recognize a lot of this code because this bit of code, we know exactly what it does. But you'll notice the first thing it does is it sets the touch event to a value of 0. So it resets the touch event. Now you'll notice that we're now only printing out values if touch event equals 1. So if I quickly touch my screen, as you can see, some values appeared on the right hand side where I touched the screen. So I had a touch event of 1. So let's see what process touch does to deal with our touch event. So every time the loop comes around, it resets touch event. Now the first thing it does is it checks, is it even worth looking for a touch event? So it's saying if millis is greater than the touch time, which is our, if you like, our timer that's looking, you know, when did I last touch something? If the gap has been long enough, and at the moment I've set it to 220, which is 0.2 or 22 of a second, what it says is if that's correct, we'll reset the touch timer to millis plus our debounce sensitivity, and so when we go round again it'll check that again. If you don't understand the millis timer system, go and take a look at the Digital Town website, the lesson on millis, but you will not be able to use delay when you're starting to use touch screens, because if I put a delay in here, any other code that I write in the main loop will wait until the delay ends. So basically nothing will happen and your screen will act in the most horrible way, and you'll regularly see people, you know, whinging about things going wrong. It's because they're using delay instead of millis. Millis is a bit of a lesson to learn. It's not that complicated, but it is worth the time investing to learn that. Now, if you remember earlier on in some of the scripts, we had a value of tp.z, which was giving a value of -1. And those were values that were appearing when I wasn't even touching the screen. If you want to see it again, just uncomment this line. I've taken it out because I really don't want to see that line anymore. But what I've done is I've said, okay, not only do we have to have a millis that is greater than the touch time, but when I then check for a touch, is there actually any pressure on the screen? Is it greater than 0? Now, just a little bit of advice here. I have had a couple of screens where they would put false values in themselves up to about a value of 10. So sometimes I've actually put in a, you know, tp.z is greater than 50. Again, that's for you to tweak with your settings, but if you can get away with tp.z is greater than 0, then that's fine. You'll soon know because you'll see false positives coming down here. Now, once we've checked that we've got a real press rather than an illusionary touch that's come through, once again I've got my same calculation for X touch and Y touch, And then what I'm doing, if you remember before, I said that it's possible that the touchscreen system does not align fully with the LCD screen. So if you remember, you could move your probe to the left past the boundary line and get a minus sort of value. So what we're saying is we only want touches that are within our boundary box. So what I'm saying is that if the X touch is now greater than -1, so it starts at 0, and the X touch is smaller than 400, so it's 399 or less, and the similar thing with the Y touch, I'm saying if it's doing that, then I'm going to accept this as a touch event, and touch event equals 1, and when touch event equals 1, it exits the function of process touch, and it comes into this function again. And we're then saying, so if we've got a real touch event, then let's print out the values. And I'm now going to start touching my screen to get some values on the right. And I'm just touching at different bits. I'm getting a little blue line shooting across to the right place I'm touching. And there you go. That's how that works. So at this point now, this area here is where you would start to place functions that deal with a touch on your screen if you're getting it to do something else. Now in the next sketch, what we're going to do is do a very simple button to show how that would work. Okay, final sketch for the day, and again let's take a quick look at the changes. Now in the setup, the main change is I have added a call to a function called button off. Screen press is there as before, so I've created two functions. One is called button on, one is called button off. Now when the button is on, bringing around another very dodgy picture, when the button is on, as you can see, I've got a square. Sorry, when the button is off, I've got a square. And when the button is on, the square fills with yellow. Exciting. So how does it work? Right, button off, 150 pixels in and 100 pixels down. I created a button 100 pixels wide by 100 pixels deep. Now if you'll notice, that is a black rectangle that I've drawn. Now, the reason for this is if the button goes on, it'll leave a yellow background. If I don't put a black box over it, it will stay yellow. It then draws the white rectangle, the white border around the edge of that button. When the button is on, it does, instead of a black fill, it does a yellow fill, and again it does exactly the same thing. This is a very, very simple sketch just to see how this works. So two functions, one to turn the button on, one to turn the button off. And of course I don't want the button to be turned on until I press within the boundaries of the button on box. So the good news is we've got our function screen press. The good news is that process touch, that function that we've seen before in the last sketch, we don't have to change at all. All we know is that we're going to get our touch points come out of it. So few little things that we've added here. So what we're going to say is that I have a button state. This keeps track of whether the button has been touched or is not touched, and I've got a button timer because instead of turning the light off in the button, it's going to be turned off on a timer. We've got our X touch and our Y touch location as before, and this is how you start to, if you like, process your script to work out if you've touched a button. So let's do our process touch. We know that if a real touch has taken place, touch event will be 1, so it's going to be greater than 0. So we have an if statement here, and this is an if statement with a lot of ifs in it. So I want the touch event to be greater than 0. I then want the button state. So when my button state is 0, I'm saying that my button at this moment is switched off. So I need the button state to be smaller than 1. I then need X touch to be greater or equal to 150, because that, if we go down, is the left hand boundary of my button box. Going back up again, hang on, where are we gone? Where's my if statement gone? So then I've got, and then if the X touch is smaller or equal to 250, because my box is 100 pixels across, so 150 plus 100 gives me 250. I've then got greater, or the Y has got to be greater or equal to 100, and it's also got to be smaller or equal to 200, because my box starts 100 pixels down and is 100 pixels deep. Again, if you're on a small resolution screen, that might not fit within your screen boundaries, so you may have to change these values and the size of the boxes in here. However, what I'm now saying is, if all of those criteria are met, then call the function button on. Button on immediately, as we've seen, draws the button in a yellow format, and now it says that the button state is equal to 1. We also set the button timer, so now I'm saying that the button timer is millis plus 500, so it's going to keep the button lit for half a second. Now the alternate, because don't forget that this screen press function is running non-stop, so in this case I've actually allowed it to be used to turn the light off. So I've got this function, this if statement that's being used to turn the light on. I've then got a set of an if statement here that says if there's no valid touch event coming through, so touch event is smaller than 1, and the button state is greater than 0, so the light is turned on, and millis is greater than the button timer, so our time has gone past the half second that we allowed, then call the function button off and set the button state to 0. So now what you should be able to do, if all of this is working, is you should be able to touch the button, take your finger off the screen, wait half a second, and the light will go back out, and then you can touch the button again. Now the reason for doing this very, very simple sketch is to show you that basically if we had 10 buttons, then obviously we would have to have 10 versions of this to work out which button is being pressed at any one time, and we're also going to have to turn buttons off and do different things. There could be code in here that says not only are we going to turn the button state on, but at the same time we might say, you know, I've got a particular controller that I've built for some model railway equipment, so it could be that when the button turns on it plays a sound. So my code to play the sound would be in here as well. Now as your script gets bigger, and if you follow the oscilloscope project, you'll start to see that there will be multiple buttons within that project using a touch screen, and that will, you know, as I share that code later, it'll explain how to deal with multiple buttons. But as you can see, in a very simple format, this is how you would deal with buttons. You could do a similar thing here, and you could say if the touch event is smaller than 1 and someone has pressed the button again, then I want to turn it off. That's some experiments for you to deal with later. But I think this video has gone on quite long enough, and I think it's time to sort of draw it to an end. So I hope this has been useful to you. It's quite a complicated subject, touch screens, but if you can get these basics sorted out, then the rest of your time working with a touchscreen becomes so much easier. So again, if you know, you've liked it and it's been helpful, you know, if you've got time, click the like and subscribe button, and I hope to see you in the next video. Bye for now.